Hello everyone, I'm the presenter for Microtest, and I'm here to introduce you to Microtest company. We are a company that specialized in measurement technology, engaging in the research and development as well as manufacturing of electronic measurement instruments. Our applications span across various industries, including electronic components, aviation, research, power, new energy, and medical. The Taiwan headquarters was established in 1993, situated in the Far East Science Park in New Taipei City, with 6 direct branches globally. In addition to marketing our own brand, we are also a renowned OEM and ODM partner for international instrument giants, including Japan and Taiwan. We have earned recognition as an ODM LCR meter by prestigious U.S. national laboratories. Over the years, we have dived into the market, understood customer needs, persistently innovated, and provided customers with reliable, precise, and cost-effective measurement instruments, establishing ourselves as an excellent brand in the global electronic testing and measurement industry. We offer customers a range of 10 product lines, including LCR meter, impedance analyzer, DC bias current source system, Hipot Tester, transformer tester system, impulse winding tester, motor stator rotor test system, cable harness tester, power meter, multi-channel component tester, wireless charger automatic test system. Guarding global electrical quality for over 30 years, there are some key milestones for us. In 1993, we were founded in the Far East Science Park in New Taipei City. The following year, in 1994, we became the first company in Taiwan to introduce cable harness testing instruments. In 2001, our Suzhou factory was established, and we acquired the well-known UK instrument company Winker. Post-acquisition, we market ODM LCR meter, impedance analyzers, and transformer test instruments globally. In 2007, we unveiled an integrated test system for electric motor stator rotors. In 2008, we introduced an integrated test system for transformers. In 2009, we presented the introduction magnetic saturation current test system with a current capacity reaching 120 amps. To date, we are globally recognized providing the highest current of 320 amps magnetic saturation test system. In 2013, we established our Kunshan branch. A significant milestone in 2015 was being the only company in Taiwan to launch a high-frequency impedance analyzer capable for testing frequency up to 50 MHz. In 2021, we launched a new generation of cable tester, followed by a new generation of impulse winding tester in 2022. In 2023, we are set to unveil a power meter with waveform analysis capability. Testing instruments are an integral part of the electronic technology industry. Founder Michael Zhou places significant emphasis on research and development, continue innovating and researching products to meet the diverse needs to various electronic industries, including consumer electronics, electric vehicle electronics, semiconductors, aerospace, intelligent healthcare, and academic research units, providing cutting-edge testing solutions. Our core expertise lies in the measurement of magnetic components. In the electric vehicle industry, we provide insulation reliability testing for Tesla motors. In many major including factories, we've implemented various automated lines, including Fenghua High-Tech, TDK, Delta, and more. To date, Microtest has been in global marketing for over 30 years, serving users in more than 80 countries. We have a total of 6 direct branches worldwide, including our headquarters in Taipei, an office in India, and facilities in Suzhou and Dongguan. Additionally, We have established distributor points in various countries. Let's review Microtest top 10 product lines. Our product lines include the LCR meter, impedance analyzer, DC bias current source test system, and safety Hipot Tester. Also featured are the transformer tester, integrated transformer test system, impulse winding tester, and electronic motor stator rotor test system. Additionally, we offer a cable tester, power meter, multi-channel component tester, and AT automatic test system. Now, let me guide you through the main application and highlights of each of our top 10 product lines. First and foremost, let's explore the LCR meter and impedance analyzer. In the LCR meter and impedance analyzer product line, we provide measurements from low to high frequencies, including basic LCR meter for frequency below 1 MHz and high-frequency impedance analyzer from 1 MHz to 50 MHz. We offer comprehensive impedance testing for various components. Beyond precise measurement instruments, we excel in feature customization. For capacitive components, including semiconductor materials, we provide DC bias voltage isolation boxes for measuring bias characteristics, supporting tests up to 2000 volt. Moreover, the impedance analyzer supports equivalent circuit model analysis. This feature is crucial engineer steering with components like inductors. For instance, in the manufacturing process, even with the same materials and winding techniques, two inductors may exhibit significant electrical difference. Our impedance analyzer aids in detailed impedance analysis, offering a valuable resource for various components type. The 6632 impedance analyzer offers a test frequency range from 10 Hz to 50 MHz, built-in DC bias voltage of ±12 volt with an option for additional DC bias current source, reaching a maximum of 320 amp. The screen can display 4 parameters set simultaneously, enable simultaneous AC and DC measurements. It also supports equivalent circuit model analysis, with basic accuracy reaching ±0.08%. The analyzer includes built-in dielectric constant analysis for materials like plastic, ceramics, or PCB. The 6630 series LCR meter is a high-frequency, high-speed LCR meter with a test frequency range of 10 Hz to 50 MHz. Basic accuracy reaches ±0.05%, and it offers rapid measurements in as fast as 3 microseconds. It features automatic potential compensation, simultaneous AC and DC measurements, and a switchable output impedance of 25 ohm or 100 ohm. The 6360 series of LCR tester is a fundamental LCR meter with test frequency of 20,000, 100,000, 200,000, 500,000, and 1 MHz. Basic accuracy is ±0.05%, and it provides a 100 ohm output impedance. The screen displays 4 parameters set simultaneously, featuring a 7-inch color screen. Additionally, it supports PC connection software for scan and analysis, making it an efficient choice for basic laboratory experiments for equality inspections. Now, let's dive into the production of the DC bias current source test system. The DC bias current source test system comprises an LCR meter or impedance analyzer equipped with a DC bias current source. In the low and high frequency categories, we have the 6350 Plus series, which is an LCR meter with a built-in DC bias current source offering frequency response at 200 kHz or 500,000 Hz. The DC bias current can reach up to 320 amps. For the high-frequency segment, we provide the 6632 Plus and 6632S Plus series, primarily consisting of an impedance analyzer with a built-in DC bias current source. The frequency response can go up to 10 MHz, and the maximum bias current output is 320 amps. The system is designed for testing magnetic saturation and temperature rise current in inductors or magnetic components. But what is the ISET magnetic saturation current? Typically, inductor manufacturers define the magnetic saturation current as the base current by causing a 10 to 30% decay in inductance relative to its initial value. This definition is crucial because inductors, especially power inductors, contain magnetic cores that can undergo saturation. When the magnetic flux reaches a certain level due to a specific volume of ferromagnetic material, it stops increasing. If you increase the current of the turns further, saturation is reached, and the inductor loses its functionality. The magnetic saturation current is an instantaneous value. Once it reaches a certain current, the magnetic core saturates. Therefore, in circuit design, we must ensure that the maximum current through the inductor does not exceed its saturation current. This system enables engineers to analyze the magnetic saturation current curve for inductors. On the testing screen, engineers can clearly observe the extent of inductance decrease, displayed in different percentage values, providing an intuitive way to test magnetic saturation current. This system also conducts temperature rise current analysis for inductors. IRMS refers to the rated current, also known as the temperature rise current, where the surface temperature of the inductor rises to a certain level during application. This temperature is typically defined above 20 degrees Celsius or below 40 degrees Celsius. The internal temperature of the inductor increases with the rising current due to presence of parasitic DC resistance. IRMS is a crucial parameter in the inductor industry, representing a reference of the working limits of the inductor. Microtest method of measuring temperature rise current involves simulating the working current of the inductor for temperature rise measurement. Temperature rise is based on DCR measurements, calculated using the temperature coefficient formula of copper. The 6632 Plus and 6632S Plus series DC bias current source test system consisted primarily of an impedance analyzer with a built-in DC bias current source. The frequency response can reach up to 10 MHz, and the maximum output is 320 amps. It offers scan analysis functionality including ISET curve analysis and temperature rise current analysis. The 6632S Plus series additionally supports equivalent circuit model analysis. This system also analyzes the permeability of magnetic materials internally for magnetic core material analysis. The images below provide an introduction to some scan analysis functions, where different currents are applied to observe the resulting changes in inductance values. This includes the analysis of the saturation level of the current and the scanning analysis of temperature rise current. The 6360 Plus series DC bias current source test system is primarily composed of an LC ammeter with a built-in DC bias current source. The frequency response can reach up to 500,000 Hz, and the DC bias current source output reaches a maximum of 320 amps. This system is designed for testing the magnetic saturation current of inductors. It features multi-step mode, allowing testing of the decrease in inductance values under different currents. Meter mode for simultaneously displaying 4 parameter sets, and DCR measurement functionality. Next is introduction to the Hipot Tester. Microtest Hipot Tester is a 3-in-1 testing instrument, providing AC, DC, and insulation resistance test. Testing channels include single-channel, 8-channel, and multi-channel scanning boxes, supporting up to 72 test channels. In terms of voltage output capabilities, AC provides 5000 volt, DC provides 6000 volt, and insulation resistance can reach up to 12 gigaohm. Testing the safety compliance of a production line can be time-consuming. To enhance production efficiency, Microtest Hipot Tester offers a multi-channel measurement solution. When paired with the 7631 Hipot Tester and a multi-channel scanning box, it can span up to 72 sets of test channels. This system also supports PC. Now, let's explore the transformer testing instrument, a comprehensive product for transformer testing. Microtest transformer testing instrument is a desktop measurement device that integrates all the electrical parameters needed for transformer into one unit. It primarily measures inductance, leakage inductance, capacitance, DC resistance, AC resistance, and turns ratio. The product line includes the 5260 series and 20 channels, and the 5460 series with 48 channels. Test frequencies are provided at 200 kHz, 500 kHz, and 1 MHz. Additionally, we have integrated transformer testing with high voltage, including the 2-in-1, 3-in-1, and 9560 series. In the 2-in-1 configuration, we have integrated transformer safety testing with low voltage, allowing simultaneous testing with handstand, insulation, and low voltage electrical properties. In the 3-in-1 configuration, besides safety Hipot and low voltage testing, we have incorporated impulse winding testing, creating an all-in-one high and low voltage transformer test system. In the 9560 series, we've integrated an AC source into a 3-in-1 configuration, enabling dynamic testing of transformers. In addition to providing precise measuring instruments for transformer testing, Microtest offers customized picture capability for different transformer products. Regarding turns ratio measurement, we provide two methods. Turn ratio measurements is crucial because it determines the relation between the input and output voltage of a transformer, enabling various voltage transformation. Therefore, we offer two ways to measure turns ratio. One is called the voltage method, where AC voltage is applied to the primary coil, and the AC voltage of the secondary coil is measured. This is done to confirm the turns ratio and phase relation between the coils. The other method is the inductance method, where the inductance value between coils are measured, and the turns ratio is calculated using the inductance value of the coils. This method provides more accurate results for transformers with significant leakage inductance. Let's move to the impulse winding tester. The impulse winding tester is designed primarily for testing the insulation reliability of wound components in winding processes. The product line includes the latest generation 7750 series, the 7700 series, 7703 series, and the multi-channel 7720 series. In the latest 7750 impulse winding tester, the pulse voltage output capabilities are 10 kV, 5.2 kV, and 1.2 kV. It features a high sampling rate of 200 MHz, a highest testing speed of 10 times per second, and also supports breakdown voltage testing. The Microtest impulse testing has received acclaim from major US electric vehicle manufacturers and has been widely adopted in testing applications. As we dive into the world of impulse winding circuits, the importance of insulation reliability for wound components like inductors, transformers, and motors become paramount. With the rise of new energy, electric vehicles, photovoltaic industries, and advancement in power technology, the demand of the safety and reliability of wound components has increased. Typically, component manufacturers use Hipot Tester to check the voltage resistance and insulation capabilities. However, these tests often overlook layer-to-layer short and short-circuit issues caused by defects in the winding wire, such as scratches, fractures, or incomplete short circuits. For instance, if a portion of the coil in a motor winding is directly short-circuited, it cannot fulfill its inductance function. This leads to the asymmetrical magnetic field compared to a well-functioning motor. The remaining coil currents increase, causing vibration, high current, reduced output, and potential issues like noise, heating, or even burning over time. Traditional low voltage or high-power testing methods are not ideal for detecting layer-to-layer short circuits. Low voltage tests with a typical LC ammeter may not reveal abnormalities due to the low testing voltage. On the other hand, high-power tester, while using high voltage, operate at frequency 50 or 60 Hz that simulate a short circuit cannot detect layer-to-layer short circuit defects. To accurately measure impulse winding circuits, a non-destructive post-high voltage testing technology, such as the one provided by Microtest 7750, is recommended. The impulse winding tester, Microtest 7750, offers pulse voltage of 10 kV, 5.2 kV, and 1.2 kV. By measuring the damping and attenuation waveform generated during charging and discharging, deviations can be identified, indicating layer-to-layer short circuit issue. When testing for impulse winding circuits, the production line needs to establish a standard waveform for a known good product before comparing it with products produced on the line. The 77 series supports 6 comparison modes, including total area comparison, opposite area difference comparison, second-order differential comparison, waveform comparison, power factor comparison, and jitter number comparison. The latest generation of the 7750 impulse winding tester boasts several key features: extremely fast testing speed, up to 10 tests per second, support for 6 comparison modes simultaneously, pulse voltage output of 1.2 kV, 5.2 kV, and 10 kV, support for breakdown voltage testing, USB host interface for convenient screenshot capture of test screens by engineers, support for 4-wire measurement technology to meet the measurement needs of low inductance components, critical for breakdown voltage testing in insulation reliability testing of wound components, setting of start voltage, end voltage, and minimum climb of start voltage for wound component testing, verification of product with 10 voltage in second-order differential and power factor comparison mode, activation of second-order differential comparison mode for measuring, one-piece mode inductors, specify detecting leakage issue caused by welding. The table below illustrates the improvements in the new generation of the 7750 impulse winding tester compared to the old model. Increased testing speed to 10 tests per second. Additional of breakdown voltage testing. Addition of USB and LAN interface. Introduction of second-order differential comparison mode to meet the measurement needs of one-piece mode inductors. Let's explore the motor and electronic rotor test system. Microtest in the field of motor measurement primarily offers testing of stator and rotor semi-finished products. The stator testing station integrates the necessary measurement items, including Hipot, impulse winding test, DC resistance, inductance, and rotation direction test. The product line includes the 6910 8-channel 6913 13 channel, and 6917 17 channel test. In the 6920 rotor testing system, we integrated Hipot, impulse winding test, DC resistance, and wire resistance into one-step measurement station, providing 24 and 48 test channels. In the face of a global labor shortage, the Microtest Station Rotor one-stop testing system aims to save manpower. It consolidates all high-voltage and low-voltage testing items into one workstation, offering multi-channel customized sentences and PC programmable capabilities. Now, let's delve into the cable tester. Microtest cable tester is primarily used to check the conductivity, short circuit, withstand voltage, and insulation performance of wires of connectors. The product series is mainly divided into the 4-wire measurement 8761 series, a 2-wire measurement 8740 series, and a specialized tester for USB Type-C products. Regarding withstand voltage output, AC can provide up to 1 kV DC with a maximum of 1500 volt, and the highest insulation impedance measurable is 1.2 GΩ. For test points, the 4-wire measurement can handle up to 512 points, while the 2-wire measurement can handle up to 1024 test points. The Microtest cable tester combines low voltage and high voltage testing items, including short circuit test, conduction impedance test, AC withstand voltage, DC withstand voltage, insulation impedance test, and component characteristic test. For conduction impedance test, both 4-wire and 2-wire measurements are provided. If your wire connectivity product falls into a low resistance category, almost in the mil-ohm range, it's recommended to choose the 4-wire measurement machine. The wire tester offers multi-channel customized test pictures, the option to purchase PC connection software, and barcode scanning test. Now let's explore the power meter. The Microtest 7130 power meter is equipped with waveform analysis capabilities. Its testing screen not only displays numerical values but also allows waveform analysis. With a bandwidth of 100 kHz, it features a 100-level slope analysis, automatic integration, and measures parameters like current peak vector. The unique current range spans from 0.005 amp to 30 amp, making it suitable for production line testing in industries such as photovoltaics, power supplies, inverters, and household appliances. Next, let's introduce a multi-channel component tester for the PCB industry. Designed for the PCB industry, the Microtest 9332 multi-channel component tester employs multi-channel LC emitter technology, offering 64 sets of tests simultaneously. It can measure 32 sets of capacitance of inductive values and support various modes, including meter mode and calibration compensation functions. This tester efficiency meets the requirements of multi-board testing in the PCB industry, with testing frequency of 200 kHz, 500 kHz, and 1 MHz. In PCB production line, you often encounter coils formed by attaching copper foil. These coils function as inductive components, especially in wireless charging coils for products like RX or smart wearable devices. The impedance characteristic of these coils vary due to factors such as wire diameter, turns, and the magnetic materials they are matched with. In the production line, poor process can lead to a wide gain gap between the coil's conductors. This in turn increases the parasitic capacitance or resistance on the copper foil. Whether it's an increase in parasitic capacitance or resistance, It alters the impedance characteristics. For such coil boards, traditional PCB electrical tester for open short testing may not be suitable. This is because a coil formed by attached copper foil creates a loop, and the coil itself presents a short circuit state. Therefore, testing just for open short without proper consideration is meaningless. Microtest multi-channel component tester addresses this issue. It offers 64 sets of test channels at once, allowing the simultaneous measurement of 32 sets of coil boards. The system supports multi-step measurement functions and compensation deduction functions. For fixture wiring, each path line length is compensated for, achieve precise measurements and efficient testing. Now let's dive into the world of automatic test system for wireless charger. The Microtest 9901 wireless charger automatic testing system is designed specifically for automated testing for wireless charger products. It provides 4 sets of test channels and integrates electronic loads with DC power supplies. Under dual-cut fixture testing, it achieves high efficiency measurements. The entire system can be controlled through PC programming, comparing input-output, protection testing, and foreign object detection. It is capable of testing products up to 150 watts. The Microtest 9901 wireless charger ATE can measure power products up to 150 watts. Wherever you are dealing with finished or semi-finished TX or RX products, this system can conduct input-output protection tests for power supply items. Additionally, it is equipped with RX coil for foreign object detection, ensuring the safety and quality of your wireless charger products. Thank you very much for taking the time to listen to our presentation. The above information covers the introduction of Microtest company and its product. If you have any questions, please feel free to scan the QR code on our official website, send us an email, or connect with us on LinkedIn or Facebook. Become our friend and we will keep you updated with the latest and most cutting-edge solution. Thank you. See you.